Hey everyone, this video is my presentation for the final project for the IoT class at UCSC Extension in Santa Clara. This project is regarding the application for the Arduino Yun, and this particular one, it's uploading data into the Google Sheet docs, and also it's sending Twitter to my account once certain conditions are met. For my setup, I got this Arduino Yun computer which is connected to this LCD screen. It's getting data from the DHT, from the LDR and the PIR sensor. So on the screen we have in the very first lines the movement section, which will present exclamation mark once the movement is detected. It's also presenting the light, which will vary as soon as I get some light into it, humidity and temperature. Right now we have also the Google Sheet docs, which will present the data. Right now we have to just let it run for a couple of minutes. Okay, so right now it's sending the first value into the spreadsheet, which we have in this screen right here, and this is the graphics of the data that we're getting. We're getting time in seconds, the light conditions, humidity and temperature. This is the data, the graphic for that data that we are watching right now. Of course, if we're gonna change the light conditions into the card, that's gonna reflect on in the Google Sheet docs. The light condition just jumped from 74 to 464. So I have here the console running. Here is the values going, and in here I have the Google Docs, which is saving the data right now. I'll come back in a few minutes after I get at least 100 values loaded. This one here is the collected data after around 15 minutes. We have done 128 runs. Temperature now it's 71 degrees, and I'm also controlling the light with this little gadget here. So far the graph that we're getting for this collected data is this one here. I'm gonna let the Arduino run for a few more minutes to get the final data. Alright, so after around 35 minutes and 200 runs, the Arduino finished sending data to the Google spreadsheets. We got this graph in which we can see light, humidity and temperature in a lapse of 2500 or around, it's actually 2800 seconds. That's the graph of that data. We also got to work the code into the Arduino. Something interesting that happened when I was writing the code was the device ran out of memory. So something I had to do was first in the source code I had to delete all the comments because they use some space, and I had to also use variables with the shorter name possible, and also the printouts with the shorter name possible. That's gonna make some room for data. Right now the minimum I could make the program work was with 1000 bytes for local variables. So I contacted Tembo support, and they said it was a problem of a device running out of memory, so it was overwriting data. Once I took care of that, the program, the software ran very smoothly. For the second part of the project, I set up the Arduino to send a Twitter message in which it will mention me, so that I will get notified. in the message it will ask me if I by accident maybe left the heater on at home. What it's doing, it's checking the PIR sensor and also the temperature, so that it will send the tweeter only if both conditions are met. One, there is nobody at home, there is no movement, and two, the temperature went in a value higher than 77. Right now, as we can see in the screen, temperature is 71 degrees, which is not meeting the conditions to send the tweeter. Let's increase the temperature a little so that it will get the 77 degrees that we need. Okay, so we got 78 degrees, and as we can see here in the screen, we got the temperature 78, and we set the tweeter. This is the Twitter account that I set up for the Arduino. So in the notification we got this message just sent 28 seconds ago. It's saying nobody's home and temperature is 78.8 degrees Fahrenheit. Did you leave the heater on? And it's on my account, so that I will see those messages directly on notifications. For the third part of the project, which is the remote control, I'm also using the Nexmo account and the Tempo service. I'm also using the same group of sensors for the weather station from the previous projects, and it has two conditions that it has to evaluate to activate the phone calls. First, no movement is detected, and second, the temperature has to go below 50 degrees. This is how it works. This is a fragment of the source code for the remote control. Right now it's evaluating if the temperature is higher than 75, but it's just a matter of changing that condition over here. It also has two runs right now, so that I can check both options in one single run. This is my setup. It's the same principle as the previous projects. It presents the movement, light conditions, humidity and temperature. As I said, it's gonna evaluate if temperature goes over 75. So let's heat it up a little bit. Alright, so it's now presenting, it's calling, and it's also presenting in the console. So I'm going to take the phone call.
Hi, this is your Arduino. Right now it is below 50 degrees in here. Press 1 if it is okay, or 2 to end.
For now, let me just get the first option.
Okay, it is called, so I am just making sure there is no pet alone at home. Goodbye.
It just says it's called here, but it's okay, because that was my option. Right now it should get again 75 degrees, so I will be able to show you the option number 2. It's detecting movement, so I just have to wait steady. Here is the second phone call.
It's the demo. Hi, this is your Arduino. Right now it is below 50 degrees in here. Press 1 if it is okay, or 2 to end.
So I'm going to hit 2 now.
Okay, it is calm, so I am just making sure there is no pet alone at home. Goodbye.
And now I'm going to blink the LED. What to have. This is the functioning of the third option, and then after this it goes back to the weather station. This completes this part of the assignment. Thank you for watching.